All right, this hangout is on air. Happy Monday, everyone. Today is October 23rd, and this is episode 32 of Get Your Tech On, our show on all things DOCSIS. I'm Brady Volpe, founder of the Volpe firm and Nimble This. With us today is a special guest, Mia Calabrese. She does a lot of stuff behind the scenes, and she was at the SCTE Cable-Tec Expo last week. So, Mia, thanks for joining us.
Thank you for having me. Also,
with us is John Downey, the man who brought us the Human Guy Show to cable.
The Human Gun Show.
It says Guy Show.
Yeah,
hey, John, so thanks for joining us, John.
I just didn't know if you got your tickets to the gun show, so I had to make sure.
Yeah.
So we'll bring you some more details about what that means coming up shortly. So John is also CMTS technical leader of CISCO Systems. So John and Mia, thanks for being on the show today. Today's episode, we're going to cover some topics of what happened during the Cable-Tec Expo 2017 last week. So if you were unable to attend, hopefully we'll be able to bring you some flavor of what the show is about and give you some updates of things that we saw, we thought were interesting, and give you our take on what the show was. So anything we want to start off with? We have a little bit of a slide teaser to go into. Want to start off with that?
Why don't we start off with that?
Okay. What about, just a breakdown of how the show's a little different this year. It started in midweek, right? It started midweek, which is interesting. What's also interesting is the week before it actually snowed in Denver. So luckily we had no snow the week we had it last week. The show floor didn't open until Wednesday, which was strange because some of the workshops started on Tuesday.
Yeah, that was actually a little surprising to me because I flew out on Tuesday afternoon and just caught midway through your presentation. So,
which I'm glad you did because I was, slinging your name around a lot during my presentation. I was calling you out even though you weren't there.
Yes,
no,
thanks.
And I mentioned it that you and I were supposed to co-present. And we didn't have a whole lot of time, so I focused mainly on DOCSIS 3.1 downstream. This was Tuesday at 3:15. I was pleasantly surprised. It was a full house.
I was standing room only. It was fantastic attendance at your presentation.
And it was 3 rooms opened. It was like 102, 104, 106. So it was 3 rooms filled up. And why I was pleasantly surprised was because it was Tuesday and not even the first day of the real show.
Right.
The show floor didn't open until Wednesday. And maybe that was a good thing, right? Maybe people were already there and they had nothing else to kind of pull their attention away. So many people did, I think, focus on going to the workshops, which was good.
Yeah, and I think having the workshops on that day, if people are flying in early, as you say, getting ready for the show, there was no distractions. So people who came in on that day were definitely focused on the workshops. So it was a good day for that.
I also find it interesting that, the expo was historically meant for what is happening today. How do I do troubleshooting? How do I use what's actually available today? The Western show and emerging technologies used to be what's 5 years down the road, what's coming down the road. Well, now that those shows are gone, there's no cable show, there's no INTX NCTA show. SCTE Expo is like the last cable show in the US, big one. Now it's everything. And there is no looking 5 years down the road because of the speed of the internet. Everything's like 6 months down the road, 10 months down the road. It comes around very, very fast. So I noticed that the Expo now has a lot on full duplex DOCSIS, FTX, remote PHY, DOCSIS 3.1 upstream. These are some things that no one's really deploying yet, but we're talking about it a lot at this show. Now for my presentation, I'm like, let me go back to the days of old and let's talk about what's actually deployed right now, even though it's not heavily deployed. And that was DOCSIS 3.1 downstream. I said, here are some of the settings to optimize and get the best speed. There's no reason why we probably can't do 4K QAM on a downstream, even though many people are nervous about 1K QAM. So we talked about the efficiency of DOCSIS 3.1, some of the fallacies of DOCSIS 3.1, the pros and cons. The fact that we can do graceful profile management, and I think that's what really operationalizes DOCSIS 3.1 downstream. I didn't talk about upstream at all. Now, Joe Godis was my moderator, and he let me speak first, and I told him, I said, you let me speak first, I might not come down off that podium. So I took up 40 minutes, and I gave about 10 minutes to Doug Jones at Cable Labs to talk about DOCSIS 3.1 upstream affecting r-phy networks.
Yeah, so that's really no surprise, but anyone is going to be speaking with you.
I told him it's his fault, not mine. You know how I am.
Oh yeah, all too well.
But it was good. It was a good session.
Yeah. No, I had good feedback from several different people on the sessions. So yours in particular was a good session. So nice job, John, as usual.
Hey, one more thing I was going to add that I maybe I start incorporating into other speeches is, and I didn't do it on purpose. I started flailing around and I hit their microphone with my hand, and it just went boom, and everyone just jumped up. I'm like, hello, wake up.
That's for the people who are sleeping during your session.
I tell you, it scared a lot of people. And then I told someone else that came by my booth later, I said, yeah, I didn't really mean to do that. And I hit it. He said, you did it twice. I'm like, oh, thanks.
Oh, great.
Nice. So, all right. So,
we're into it?
yeah. So we have some just some pictures here to share from the we got during the presentation. And the first one here is just kind of what you see. So, you know, for people who weren't at the presentation, obviously,
So
if you're listening to the audio only,
yeah,
this is kind of what you see when you walk into the presentation hall. There's lots of people standing around. You see the big banner here, kind of go through here. So Burns effects here. This is walking into the exhibit hall. So there's a stampede of people coming in. Now this is the John Downey gun show.
Yeah.
So to get that going in.
I was doing like triple duty here. I had to do demo, setup, tear down, also do my speech, and also handle the booth with some of my compadres. And
I thought you were juggling the nodes over your head.
I was carrying some 7000s in the Arris node. One of the things we showed in our booth was Arris, their node interoperating with our CCAP core so that we could show open RPD. So their remote PHY working with our CMTS, and their E6000 working with our GS7000. So yeah, those boxes can be pretty heavy. Just zoom right in there.
Yeah. So then this is right at the show opening. We took proof that all three of us were there. Getting out onto the show floor, you can see there can be quite a few people. There's your Merce, your man Merce there. Or I think
we like to call it a satchel.
Your satchel, John.
Satchel. Hey, is your hotel pager friendly? Anyone knows the reference to the Hangover movie gets it.
Yeah. So we had an announcement that we made at Expo, which was a new partnership we have with a test equipment company called VX.
Right.
They're now white labeling and distributing our PNM application. So we've added them to our list of partners that are doing that. So this was
including CISCO.
Including CISCO.
Who's been doing it for a while, and some other company, and Decorum.
Yep. So it's just expanding our footprint and expanding the number of customers that are able to access and through different channels our proactive network maintenance platform.
Which, of course, we still love greatly.
Yep. So bandwidth for this podcast is brought to you by NimbleVis.
So was that an announcement you made, or
was it was announced?
Yeah, there was a press release at the show that came out on our partnership with VX. Nice,
congratulations.
Yeah, thank you. So more pictures. This is at the CISCO booth.
Yep.
And then we had a white paper that we did with ComSonics, some testing and stuff on
pressure tests.
Yeah, so basically, I'm sure you're familiar with the pressure testing leakage tools. Basically, when you identify a subscriber's home that has impairments, particularly through using proactive network maintenance tools, you know that there's problems either with the subscriber's drops or there's problems with their in-home wiring. And what we found over time is you can spend a lot of time identifying exactly where the problem is. You know, is there a crack in a cable, a crack in the drop, a loose connector, where is the problem in the subscriber's in-home wiring? So the testing that we've done with ComSonics is you disconnect the subscriber's drop, you connect this device that injects a lot of high-level RF signals into the subscriber's home, and then you walk around with that little handheld device you see sitting on top of our white paper, and it identifies where the leaks are, whether it's on the drop, on bad connectors, on the house box, or inside the house. And it can really reduce the time to find any impairments wherever they are on the drop or inside the house from, you know, a couple of hours to 15 to 20 minutes. And this just dramatic. Go ahead.
But you're saying impairments, you really mean cracks in the cable,
bad connectors, loose connectors, corroded connectors.
It was actually a pretty, it was a field test that we did for over a week, no, about a week, but it took a lot of planning in advance with a cable operator. And we actually went to real subscribers' homes. We had no expectation of like what would happen, so we just thought it'd be interesting to do. And we had 100% success basically for every house we went to. So it was pretty interesting. And I think this ComSonic unit is unique. I don't think it's the same as what some other people have on the market, from my understanding. But then again, I think what we wanted to do was maybe have just a hangout talking about this, because it was pretty interesting, and we're looking at doing it with a couple other operators too now. So, but
you can download the white paper from nimblethis.com. That's on our website.
Or go to ComSonic too.
So.
Look.
Oh yeah, more pictures of John.
Oh, this was interesting. This was at the Arris booth, and it was the only example that we could find of full duplex.
Yeah, it was full duplex DOCSIS. So they had a demo of full duplex DOCSIS in QAM, and they were just showing. They had a nice visuals where you could disable the echo canceller, and you could see the video dropout and the bandwidth and the upstream dropout. It was just a nice technical test. So, Cable Labs just released the specification on full duplex DOCSIS, and
just the PHY layer.
Yeah, so the PHY layer. What Arris was doing was a nice real-world test of, yes, the theory. Listening to the theory is good, but seeing the theory
in
actually
action.
work is also a nice thing to see have going on.
You came over to our demo, and we started encroaching in the hallway and everything, how our demos were set up. But round to the middle of our booth and inside, there was a full duplex DOCSIS demo. I don't even know if you got in there.
No.
Yeah, we took it a step further, and we actually had spools of cable. Now we used RG6. I told them they should have used mini coax to save space, but they did RG6 or 59, Series 6 or Series 59. And they did 7 spools taps to simulate a real fiber node with echo cancellation. So it was a special fiber node, and it was 7 taps. And then it was modems. The modems didn't have echo cancellation, but they were a different diplex filter split, so they could do upstream up to 204, whatever it was. So we had overlapping spectrum just like this, and we showed how to operationalize this, you're going to have modems transmit like a CW carrier, almost like a sweep signal, so that you can discover which modems will affect other modems. So then you put the modems that interfere with each other into an interference group. So you have transmission groups, you have interference groups. Once you can identify modems that will affect each other because of group delay, microreflections, port-to-port isolation, maybe everyone off the same tap will be in the same interference group because they're going to have port-to-port isolation issues, or one person's downstream is going to affect the other person's upstream. So you don't allow full duplex in an interference group. So we call it full duplex, which is true, but it's actually simplex, or I like to say half duplex, but isn't that like an oxymoron? Half?
Yeah.
You really call it simplex. So in an interference group, you have half duplex or simplex. But when I'm transmitting, maybe someone that's a tap 5 spans down, they're not going to be in the same interference group. So their downstream could be receiving downstream while I'm doing upstream. And that's where the full duplex comes into play. So we had a demo there as well, and it was kind of cool.
Yeah, we didn't have, honestly, it was impossible to get inside your booth.
Yeah.
I know.
So.
Your booth was really quite crowded, but I think this, I mean, back to your point earlier, where, SCT Expo used to be more like what the technology is now. I think this is an example, really Cable Labs is just releasing the phi spec, and we're still seeing technology that's pushing out well beyond what is available to operators now.
What people are actively using right
Right.
now. The other thing that I thought, just because we're on the topic a little bit, I had been talking to a cable operator from Switzerland, who actually was saying they specifically like coming to Cable-Tec Expo because of the papers, and because they were like, there's really no other trade show that is as technically competent, I guess.
Yeah.
So
yeah, absolutely.
it was actually pretty interesting to hear that from someone other than an American who's coming here specifically because they want to definitely go to all the
Yep, the technical sessions, and see also the technology that's on the floor.
I think the unique thing is you're getting papers from not just vendors, but also MSOs and operators. So you're getting real world experience, not just theory, not just a presentation smacking of sales.
Marketing promotion.
It's not even a hidden agenda. It's not even subtle. Some are like just marketing material. And it's like, this is supposed to be generic enough that you're not talking about your specific functionality, but you want to give meat and potatoes too. Like for instance, when I gave my presentation, I said, here are some commands I use on the Cisco CMTS. Please, go to your CMTS vendor and get the equivalent of command, because it's all technology. So I'm not trying to promote a Cisco device. I'm trying to promote the technology itself.
Right.
Yep. All right. So moving along here. Okay. So talk to Alberto Campos. And so for people who don't know Alberto, he works for Cable Labs, and he is someone who is really the founder of Proactive Network Maintenance, but he's just
a very brilliant man.
Yeah, he's involved with so much technology, and someone that I really like to always meet with and just see what's on his mind, because he's normally on the real cutting edge of a lot of technologies, and just a great guy.
Yeah.
I have a lot of respect for Alberto. So anyone gets a chance to meet him, say hi.
Oh, there we go.
And then next up,
runner.
Asaf. So John, probably remember Asaf from the last hangout he had. So I got to spend some time with him and talk about the technologies he's working with at Harmonic. And we talked about, I think another great hangout that we would have, perhaps the three of us again, is to do a deeper dive into r-phy technology, because there was so much r-phy.
Well, we were actually, he gave us a demo of what they're working on, and also we were thinking it would be nice to also see if we can get someone from Arris to come on. I think we have someone in mind, and we stopped by a couple times at the booth to see if she was available to talk to us. So I'm going to get in touch with her, but I think it'd be nice, like you said earlier, I mean, everyone is doing their own thing and how they're getting there, but it would be great to have, everyone just talk about the technology, kind of like how we talk about the technology when we're just hanging out at a bar at night, not really talking about, give me we're not going to buy that Cisco node from you, John. We love you, but we're not going to do that. But, it's interesting to talk about the tech and how it works.
Yep.
Yeah. I mean, the last hangout we did with myself, Brady, and Asaf was virtual CMTS, cloud CMTS. And then I brought up, it says, it's not going to happen without remote phi. So yeah, I mean, us going deeper into the remote phi side of it, I think bodes well. Maybe there's still some misconception of what remote phi really means, and how we envision this going further and further and deeper and deeper. So that's one of the things that we showcased in our demos as well, is open RPD. It's all open. So you already have an investment in the outside plant. You're not going to rip out all your Arris nodes and put in Cisco nodes if it's proprietary to do remote phi with the Cisco CMTS core. So we got to make sure that the outside plant and the CMTS side are interoperable. And that's exactly what we're showing now.
Yeah, and I think that's really important for operators, because they want to be able to mix the technology back and forth between one vendor and another vendor. So having that integration, the interoperability that you're doing at the show, really, really, really good for operators in the industry.
Yeah.
So So this is another one of our partners, Zecorum. Art Skinner here. He's at the show doing lots of demos. He's also
super
a great
friendly guy. Yeah.
Yeah, we love Art. So
yeah,
spent a lot of time with him.
Zecorum?
Yeah, this is Zecorum. So they're also one of our partners.
And Art also likes to bake. I'm just throwing that out there.
Did he get some special ingredients while he was in Denver?
Here. This is a little quicker. So this was actually, this is John, if you see the picture. I think down there is the Arris node, and I don't know who.
Side,
yeah.
PBN.
PBN, right? And then that's the white box above it. That's Teleste. And then you can also see BK and then Victor.
This is the Vector one over here.
Victor.
So this is where you're showing your interoperability, and this is your node up here.
We took that, we took that GS7000 node a step further, and so it's the same housing and same footprint, same form factor, but in the middle in the lid there, it's an RPD or a remote PHY device. So there's no amplitude modulation, there's no transmitter receiver, there's no overlay here. It's all digital 10 gig link coming in. That's the blue fiber going in. But the amplification, that's where all the RF happens. This was called the iNode. So the intelligent node has no plug-in pads and EQs. It basically is controlled via software. You know, and you and I, Brady, working at CISCO Electronics, 20 years ago, whatever it's been, we've talked about that a long time ago, but now the technology is finally catching up where we can do this economically, where we could put in surface mount technology and then be able to drive things via SNMP or whatever communications we need to talk to the device and change the equalization, change the padding, change the RF channels coming out of this thing remotely. Now I plugged an iPad into a USB port to set it up, but eventually, this will be via the network. So you could be sitting at your home and change the output of this thing whenever you want.
Yeah, I think technicians, I think there's two things here. One, technicians don't have to walk around with a tackle box full of pads and equalizers, which is spectacularly awesome. I think two, technicians don't walk around with pads and equalizers and make adjustments unnecessarily at times, maybe because they don't completely understand how this device, maybe there's a change in the network. And so they think, well, I'll compensate because, someplace there's some additional loss that's come in because something's been damaged in the network. So what do? They adjust the padding in the node or in an amplifier, and no one knows that was done. So then they fix the repair, and now the levels are messed up somewhere else. Having this capability, you have traceability now. When someone makes an adjustment in it, I'm assuming you probably can say, yeah, this technician logged in and they adjusted the amplifier or the fiber node in this case, and you can see what adjustments were made. And I think that whole concept, and we're seeing other vendors that are also doing the same technology where we're just getting rid of pads and equalizers and it's all done electronically. And I think that's a great technology in the industry.
Well, I mean, let's give a case in point would be when you and I worked at CISCO and people would misbalance amplifiers. We all know that the pad and EQ in front of the preamp affects your CNR levels because your levels are so low hitting the preamp. And but when you go interstate before you hit the post amp, that usually affects your distortions. So what if you called for a 10 pad and a 5 pad, but you swap the pads?
Yep.
Now all of a sudden you're overdriving or underdriving, and so your levels are proper coming out, but your performance sucks.
Yeah, and people don't know why their performance is bad. They don't realize that they switched those pads. But this is a way that you could say, here's what the plant design is. Here's what my output level should be. It should be a 5 and a 10 pad, and you can automatically push that configuration into the fiber node, and it should be right always because you've put that design in there.
Yeah, and what we envision is these nodes would be actually pre-set up in a warehouse, and then a technician would take it out to the pole. If you look in the lid, there is a QR, a really small QR there on the RPD. There would be an app on the phone that would scan that QR and not only log in and use this what we call smart automation, r-phy automation. It would log in the MAC address of the RPD, but it would also tag this with Latin long, so you have GIS. So you know exactly where this node was placed. Maybe because of the strand mapping, it couldn't be placed where you thought it was going to be placed on the mapping software, and it actually is one pole down. But once the technician hangs it, then you know exactly where it's located.
So one other thing I was going to add just about this is that while we were at the show, John did do a demonstration of this node, and the video is about 11 minutes long. And so we'll post that on the website and on YouTube so people can actually watch it. But we didn't want to have it. Yeah, right. It would be a little weird.
Yeah, I don't know if I even talked about it during that when we were talking.
You didn't talk about the cell phone part of it, but
yeah. But there was one other thing Mike Whitley told me I didn't realize was we can actually shut down a downstream hybrid if this node doesn't need, say, 4 RF outputs. So instead of just putting a line terminator or a housing terminator, you could shut down the hybrid, which one eliminates potential CPD from a bad terminator, but two eliminates the power draw and heat dissipation because you actually turn down the power to a hybrid.
That's actually really nice because if you're not using that port, the hybrid's still powered, you're terminated at the port, but to your point, you're still drawing on the power supply, you're drawing off the mains power that's coming in, whether it's 60 volt or 90 volt, unnecessarily. So that's a good feature.
It's a nice way to go green.
Yes, absolutely. So, and I think I think this was pretty much the final meeting we're having with the guy from Anga. So we're getting ready for the Anga show, and then this is what's that?
How'd you get that picture?
It's a final night.
Yeah, that's
funny.
Long story behind that one.
Like, how are you so high up? You got a drone?
We flew.
Yeah. So we had planned on leaving on Friday, and then ended up spending an extra night. And so, if anyone saw us at the airport, Mia's feeling much better now. So.
It was nice weather, though. You got to admit. I mean, it was what 75 during the day.
It was very nice.
Great week,
especially because the last time they had the SCT show there was a blizzard. So I was really happy.
Yeah. And I think next year is for back. Where's it scheduled next year?
Atlanta.
Yeah, it's in our hometown, so we will be looking forward to that. So I think also in October it'll be in Atlanta. So anyone planning going to Expo next year, mark that on your calendars. I think I think the main, from my perspective, the big topic of the show was r-phy. I mean, that seemed to be everywhere on the show floor. I don't know, John, did you get a chance to walk around and see any other different perspective? Or
yeah, it's weird, and I kind of blunt about stuff like this. I always felt like, working for Cisco's bread and butter is routers and switches. So it doesn't take a rocket scientist to figure out that we want to create more traffic on the internet. Hence, we had video cameras. Hence, we had telepresence and video chat. More video, the more data bits, the more routers and switches, right? That makes sense. I mean, that's easy to understand. Cisco got into the residential side with Linksys. It got our name known in the residential side. Then we sold Linksys backs off after we, solidified our positioning on the residential side. And then I thought, why would Cisco buy SA? Well, to get set-top boxes, more video, start pushing IP. We're there. We're IP video. Why would Cisco stick with HFC plant? Here's why I think, because you want to be a one-stop shop, and HFC is very cyclical. You and I, working at C-Corp, we saw it too. People would upgrade their cable plans maybe every 5 years, 6 years.
Yep.
750, 860. 1 gig took a long time to get people to upgrade to 1 gig. Coax went from a publicly traded company to private, and then they said, all right, now that we're not being controlled by Wall Street, let's invest money and go to 1 gig. And they upgraded all their plant to 1 gig.
Yep.
Other systems are still at 860. So this HFC upgrade cycle is getting much higher again. And where it's coming at is the r-phy stuff.
Yes, and also DOCSIS 3.1 is driving upgrades in a lot of systems where they want to go to either 1 gig or 1.2 gig now. So we're seeing major upgrades, not just in North America, but also Europe and in other parts of the world that they've been maybe 750 or 860 systems, and now they want to go out to 1.2 gig or at least 1 gig.
I agree. I had a customer in Colombia, I have to say it correctly, Colombia. They were 860 or 750, and they were looking at 1 gig. I'm like, why would you stop at 1 gig? The 1.2 gig products have gallium nitride instead of gallium arsenide, and they have much higher gain, so you don't have to respace your housings anyway. So just go to 1.2 gig and be done with it. And even if you don't use 1.2, don't worry about it. At least you have it there and future-proof. So
the gallium nitride is also more power efficient. So there's multiple reasons to go to a gallium nitride and a 1.2 gig. You're getting more frequency, you're getting more power efficiency, you're getting better distortions.
Yeah, the bad thing about the 1.2 gig would be your passives have to be upgraded to 1. They usually list at 1.25, but most of the taps out in the field are probably listed at 1 gig. So if you're going to go all the way to 1.2, then you might have to change some of your passives as well. But the actives, you might as well go to 1.2 gig and just be done with it. I also like the idea of the pluggable diplex filter. So if you can pull out the 42-54 split and do an 85-102 split, that might be something that's really palatable, especially if I try to do DOCSIS 3.1 upstream.
Yes. Yeah, and I mean, the diplex filter is a good thing to bring up. I think anyone that's looking at investing in amplifiers and fiber nodes should really talk to their vendors closely about what's the roadmap on the diplex filters. Are they upgradable? They really must be upgradable. And what is the upgrade path? So I've seen different solutions with different vendors. Some of them have like 2 diplex filters in, so you can just switch and it's an automatic, easy upgrade, although I'm sure that adds more cost. But most vendors have some sort of upgrade capability, or some way that you're not locked into that diplex filter. Do you remember when we worked at CISCO or C-Corp so many years ago? We had diplex filters that were soldered down to the board. The upgrade path was called throw away the old module and buy a new one, and that's not a good solution to be considering if you're looking at investing in amplifiers and nodes moving forward.
Well, back then you used to tweak the capacitors, resistors, and the coils just to get a flat response. Then you close the housing lid and it would change again.
Yeah, and so then you put finger stock on top. It was a crazy day.
More grounding, and then so where I see it going is we're getting at the peak of a HFC cycle again, where people are going to invest in upgrading their cable plant. And if they do that, it still behooves us economically to not do fiber all the way to the home. We said this before, it's not the last mile, it's the last 100 feet. So I do envision us eventually getting to remote PHY to the tap, where the remote PHY is a small device, and it's only 4 to 8 people off of that little node. To give everybody a node like an r-phy network or a fiber to the home, that's still pretty expensive. You're talking about ripping up coax in the ground, going through people's houses. Yeah, it's still, if money wasn't the object, then we wouldn't have this discussion. We wouldn't have DOCSIS probably if money wasn't the object. Yeah. DOCSIS allows us to keep utilizing coax cable and utilizing the plant in a very well-known, structured specification, which drove down the prices of all the CPE. The CPE comes down a lot, right?
Yeah, so I think it's a good discussion, because you have people that say, well, once you get to node plus 0, why not go all fiber through the rest of the neighborhood? And I think depending on the area, pushing fiber to the home seems like such an easy thing to do. We've recently seen that scenario go where AT&T has come through and pushed fiber through the neighborhood, and it is amazing how much damage and how much irritation that creates in a neighborhood where you see reasonably sane people go insane when AT&T comes through and starts, and they try to do it is with as least destruction as they can, but yet they go and cut through people's gas lines, they cut through people's water lines, they cut through electric lines.
They cut through the cable lines.
And that's the simple stuff. That's just not talking about destroying everyone's lawns and bushes and stuff like that, running the fiber through. So if cable operators have the ability to offer near fiber optic service or equivalent service without having to be the cable operator who came through and ripped up my lawn, cut my gas line, my water line, and everything else. It's a really nice solution to be able to do that. Plus, you don't have all the cost of doing all that.
I mean, they definitely tried to be careful, but there was still some damage that definitely happened.
Yeah, it's very disruptive. I mean, it's disruptive. I mean, some people just don't even want you to mess around with their flowers.
Yeah.
Their flower bed or whatever.
And when
we
you
have
live,
invisible wall fences and stuff like that as well.
yeah, when you live in
Yeah.
HOAs have the right to refuse. Depending on the HOAs, they can keep you from coming in.
I think, yeah, I think it depends. So,
Yeah.
but
So, yeah, so I think to your point, being able to go to like an r-phy to a tap, and then at that point you have DOCSIS 3.1, or you could even do full duplex. I mean, you have speeds that can go.
That's where I think FDX comes a bigger play. FDX, you're talking about using higher upstream frequencies to get. Let's call this out for what it is. FDX is the problem it's solving is upstream speed.
Yep.
585, 5 to 204. It's still not going to get us 1 gig on the upstream. Now, if I do remote PHY to the tap and I'm a lot closer, and the only coax I have is a drop cable, I could do maybe 5 to 500 megahertz on the upstream, full duplex with the downstream doing 258 to 1 gig on the downstream. I might be able to get 1 gig, 2 gig, 3, 5 gig on the upstream. And that's what FDX solves. But to run upstream frequencies that high, we all know attenuation is bad at higher frequencies. We already have upstream power level issues already. But if the remote PHY device is really close to me, and I don't have to hit that tap with 40, I have to hit it with 0, because that's where the RPD is, that's where the PHY chip is, then that coax loss is not so bad because not much coax, and my RPD is so close.
Right.
And now because it's so close, maybe I can even do 4K QAM in the upstream, not just 1K. Sounds like a pipe dream, but it's doable.
And so we talked to, and we can't disclose, we talked to some, or at least a vendor out there, that they are talking about taking r-phy devices and putting them basically into SoCs or silicon on chips. And that will, I mean, what we're talking about will make it possible that the cost of an r-phy device and the size of an r-phy device will fit into a tap.
yeah.
I mean, that becomes feasible at that point. Not this year, but as time goes by, it becomes very conceivable that we could actually realize something like that, and the cost becomes possible. And as internet speeds go up.
Did anyone talk to you about who's going to power up these devices? Because that's still a concern. Like, if I do an r-phy device, say in the tap, do I power it from one of the subscribers? Like, how do I get power to that thing?
Solar, man. It's all solar.
I said we should be talking to Elon Musk and get the Tesla guys to work on it.
Yeah, I think those, we'll figure those solutions out. So, but if it's on a tap, we can get it off the main line still.
Yeah, but there really, at that point, there really is no main line because it's a tap location, but you're running fiber to that tap now, but maybe you still have the old coax. So, I mean, all these conversations are different depending on brownfield versus greenfield. If it's greenfield, you probably are running fiber to the home. But we're trying to deal with what we have today and keep return on investment, right? Even though that investment's been for 60 years. Coax cable.
So I would say, before this show, I was really struggling. Well, how does FDX fit in? Is it really because it only makes sense at node +0? But after this show, there were so many discussions that we have. And to your point, when you start talking about putting r-phy and tap and stuff, it really, that progression starts to make sense. There was another interesting technology with fiber that the cable labs have. I don't want to disclose that just yet. I mean, if you saw the demo, it was cool. But when you start talking about backhaul and the amount of data that comes over, there's even evolving technologies in that. So there was some really cool tech that was displayed at the expo that just like we talked about, to make virtual CCAP a reality, you need r-phy. Once we have virtual CCAP and r-phy, now we start needing more, we have more requirements on our fiber backhaul. And so there's just, we just keep having these new technologies that keep extending the life of cable in one way or another. And it's really exciting. And we see these things emerge at SCT Expo and at these shows. So I think at the ANGA show, hopefully you'll get to, you'll be there at ANGA this spring. We're going to see even more exciting things come out there.
Summer. When is it, June?
So it's always at the end of May, beginning of June. I don't have
Somewhere
a
in
date yet.
June. Just remember to bring a wallet.
I now have Android Pay, so I'm good.
Yeah,
And
okay.
I have your little sleeve here that says "Got DOCSIS," so I keep my my credit card in my phone all the time.
Yes, awesome.
I'm always good now. But I do feel like every year I'm like, how much longer does DOCSIS? What kind of legs does DOCSIS have? You know, and then we come out with something new. So we keep reinventing DOCSIS. You know, if we were like Samsung and iPhone, we'd be up to DOCSIS 10.0 by now. For all the stuff that we've done, right? Like when we do FDX, I don't know if anyone's even said officially if that's going to be called DOCSIS 4.0. I haven't heard anything.
Everything I've heard with FDX is it's an extension of 3.1. So I think we are just very we were very hesitant to go to DOCSIS 4.0.
It's like 3.0, right? We went from 3.0 to 3.1. We didn't want to say 4.0. I'm like, I would have said 1.0, 2.0, 3.0, 4.0.
Yeah.
5 or 6.0 by now.
Yes. I'm not. I can't get into the details. Or, but I don't think we're ever going to make 4.0.
Yeah, we definitely keep reinventing and getting more speed out of the pipe we inherited all these years, and we're just pushing and pushing and pushing, and we're getting better technology. So I think it's getting cheaper. It's less heat, less energy. I mean, we're in a good space. I think we're in a good space.
Yep.
You know?
So, anything else you saw, John, you want to cover?
Who did I talk to? Oh, this might be interesting from your side is, if I have common path distortion, can PNM be used to track that down? Have you done anything with the modems and PNM to maybe locate where common path distortion is? A non-linear, or is that linear? Linear? Non-linear.
No, it's common path distortion is non-linear. So in PNM and in the working group, in an ingenious working group at Cable Labs, we can see common path distortion. I would say we can identify sort of maybe what leg on an amplifier it's on.
Just by looking at the RF spectrum, right?
Yes, and we could maybe correlate we could correlate a group of modems that it's coming from. So you can narrow it down that way. There is another company that is also working on it with a different technology, but I would say there's sort of two challenges. If the plant is all analog, it becomes much easier, because you see the common path distortion every 6 megahertz in the upstream, or 8 megahertz if it's in a European system where the channel spacing is 8 megahertz. What happens though is most systems are going all digital, and in all digital systems, common path distortion just looks like an elevated noise floor. That makes it much more difficult. So what you have to start doing then is injecting 2 or 3 tones in the downstream, so you can then pick up those tones in the upstream. So that's part of what we're doing in the ingenious working group is there's some work that's been done to do that. That becomes more of an invasive test then, versus just a passive test where you're monitoring the tones, or monitoring the signals in that case.
Yeah, I stopped in, our good friend, one of the CPD hunter, Arcom. It's Arcom now, right? Arcom bought the rights to the CPD stuff, the Quiver and the Hunter, and they showcased to me a demo of their little device that would be plugged into, say, a fiber optic node, and tapping off test points, and it would inject, just like you said, CW carriers, doing all the mathematics, and basically you're doing like radar or sonar, sending the signal down, knowing the velocity propagation, and determining where the second, third order, fourth order harmonics or intermods would fall. And so even if you had maybe slight corrosion that would cause CPD, but it's not that bad to even show up on the RF spectrum, you could indicate where that fault lies, kind of like before it becomes a real bad fault. So like ingress under the carrier, or maybe the third or fourth intermod is actually lower than the noise floor, so you can't see it anyway, but they can pick it up because it's all mathematics.
Right.
And then you can find where the location lies. which I think is kind of interesting. But they also showcased what I called FDR. So it's kind of like their TDR replacement in line, but it's really FDR, frequency domain reflectometry, trying to use like a sweep pulse and then indicate where a problem might lie by injecting a sweep pulse or something like that. So I thought that was kind of interesting.
Yeah, yeah, and they also have a sort of an API, or basically a programming interface on that product, so that it can be integrated with other people's P&M solutions. So if you're using a P&M solution, so you can take that product and you're using that product, you can integrate it in and also use it. A lot of times what they're looking for, though, are effectively micro reflections. So it's basically micro reflections that are causing CPD. It's like corrosion on a connector. And depending on the level of the micro reflection, you'll still pick that up in your cable modem's pre-equalizer.
Yeah, I mean, I could do that with P&M. I mean, I get micro reflections group delay from the P&M information.
So most of the time, you'll pick that same micro reflections up with a pre-equalizer.
Okay.
And that creates a correlation group.
One other thing I saw on the floor that interested me was the small, what do you call the small attenuators? What do we call them? Pencil attenuators? Some people call them pencil.
Inline pads.
Yeah, inline pads. F male to female.
Yeah.
They make them now with filters that small, with filters, padding, step attenuators. But I also saw some equalizers, cable simulators. The reason why I like the idea is I have with DERFI, downstream radio frequency interface spec with DOCSIS 3.0 and 3.1. When you start activating more spectrum on a CMTS port, it's not just one channel, it's 32 single carrier QAMs, 32 video on demand QAM signals, 2 blocks of 192 megahertz OFDM. So you have a lot of spectrum on one single port. So if that port happens to lie 100 feet away from my optical transmitter head end, by the time you hit your optical transmitter, your levels look like this.
Right.
So either your CMTS has to do this, or you have to put something in to create equalization so you can flatten it out before it hits the optical laser. So they are making these equalizers. If your CMTS doesn't support it, you could just plug in this equalizer and get the proper tilt and get proper levels at the laser. Yeah, so it's not an active device, which is kind of good, and it's very small. So I mean, I think that was kind of a nice, necessity is the mother of invention.
Yeah. and that's particularly going to be beneficial when you're using the mini coax for cabling in a head end, or if you have a long run of cable in the head end, that you're going to see that tilt. And really, you don't want your signals coming out of the head end fiber optic transmitter when they're not flat. So I think that's a great use for the and from my side, we are implementing, and I showcased some of it at the demos. We can put some tilt at the CMTS, but according to DERFI, it's only 8 dB. So if I have to go full spectrum, say 54 to 1.2 gig, and I have 100 feet or 200 feet of mini coax on the downstream, that 8 dB is not enough. So even if I do implement this on the CMTS, I might still need 3 or 4 dB more, so I hit my levels at the laser flat. But now you run into having your CMTS engineer and your RF head-in engineer, or RF engineer or RF guy.
Those lines are blurred.
Now they're putting fingers back and forth, and it's just so much easier to have a connector or an inline tilt or cable simulator or whatever it is, and they don't have to fight with each other.
I agree. It's funny you say that is I used to say there was always a CMTS engineer, an IP guy, and then there was an RF guy, the guy that handled head end. We went to CCAP. There was a fight between the video guys and the CMTS guys because the CCAP does video. So who owns the box? So there was always a fight, and those lines have been blurred. So now it might be one guy, does the video, does the IP. We go remote PHY, we start blurring these lines between outside plant and inside plant.
Yeah, it just gets even more exciting.
Who's controlling that? So now you have the fight and the power struggle of who owns what, That's part of it's not just technology, right?
Yeah. You throw the people element in there, just like little grenades. So, all right.
But speaking of connectors, we did try to find some decent connector companies while we were at SCT, but we ran out of time to really find anyone. So if anybody's listening who has any good recommendations on...
Yeah, thanks for bringing that up, Mia. One of my goals at Expo was to go around and speak with connector vendors and also splitter, just like household splitter vendors, connector or combiners, just, you know.
But good quality.
Yes, because as we do so much work with P&M, what we're finding out is even though you think it's a good connector, it's sometimes not. Even though you think it's a good splitter, it sometimes is not. And we'd like to do a nice white paper to make good recommendations for technicians as to here's how to properly choose a connector, here's how to properly put a connector on a cable, and here's how to properly select splitters for putting in a house box.
Yeah.
So we're looking, I've actually reached out to at least 1 or 2 vendors, but didn't get a good response back because I'm not sure, I don't think I reached out to the right people. So we're kind of asking for some good recommendations, maybe to help put together a nice white paper to make sure that correct information is out there.
I mean, coming, you know, off the top of my mind, you got to worry about, you want to go to 1.2 gigahertz, so you got to get a passive that goes to 1.2 gig.
Yep.
Once you do that, you got to worry about Mocha. So if you're
Yep.
doing Mocha in the house at 1.15 gig, maybe that splitter comes with a built-in filter, a notch filter. I don't know. Or maybe you have to add a filter. So understanding the ingress coming in. And also, the big one I see is saturation of the ferrites in the device itself. So if you have a splitter that now is doing 5 to 85 megahertz on the upstream at 50 dBmV, you could overdrive the ferrites in that splitter, cause intermod in that splitter. So now all of a sudden you have port-to-port isolation. You have the ferrite material itself. Yeah, there's a lot of little gotchas there I could see that would be good to kind of cover.
Yeah, well, I told someone this. I was like, yeah, well, they said, what are you looking for at the show? I'm like, connectors and splitters. And they said, why? That's they thought that was a trivial question.
They were like, why are you doing that?
Yeah, and I'm like, it's actually, I think, a little bit more complicated than you think when you start talking about some of the new technologies we're doing. So yeah, connector people, splitter people, please feel free to get in touch with me.
Or even if a cable operator listening has a recommendation, like they think this is a really great product, you know, we'd be interested.
Yep. Yeah, even on our side, we had customers ask about a compression MCX connector. We've always done a mini coax MCX connector for our CBR8 and 10K. That was a crimp, and they wanted compression, but that compression's its real estate or its dimensions wouldn't fit into our header. So we are now working with Amphenol, I believe, to do a compression fitting in a different type of header for our new high density r-phy shelf. And that was another thing we showcased at the SCT Expo, was this new 7RU shelf for remote PHY that would be for MDUs or maybe hub sites and stuff like that, but it was remote PHY. But the RF connectors are MCX, but they're compression MCX.
Yeah.
So that's a nice deviation from what we were always using before. Because all the RF guys want to do compression.
Right.
They feel more.
Everyone feels a compression is the best connector, but actually I've found many compression connectors that were not properly connected, and they were leaking like a sieve. They were leaking as bad as some of the twist-on connectors that I found, and so again, that's why I'm back to saying I want to know what is a really good connector and what is the really proper way of putting those connectors on.
Very good.
Yeah.
Alrighty, that's all I have.
Yeah, we did still have one more question. Excuse me.
Sure.
There was a question that came in from a listener. I'll let you read it.
Oh yeah, so we'll cover just one question before we end here. I'm wanting this is that Mia said, one of our listeners. I'm wanting to advance my career in broadband technology. I'm currently a plant maintenance tech for a major MSO. I'd like to get into the engineering side. What areas of study would be best? I'm looking at a BS degree. So kind of putting this out there. What are your thoughts, John?
Wow, I never thought of myself as a counselor, a career counselor. Well, one, we know SCTE has the DOCSIS certification now. They also cover the CCNA, Cisco certifications. I believe they still cover those. A lot of this stuff is online, study at your own pace. So SCTE does cover some of that stuff. Outside plant to engineering. I mean, anything you learn with DOCSIS, you know, you could say read the freaking manual.
Yeah.
The DOCSIS spec is out there, but you know, it'll put you to sleep. And now that we went from 1.0 to 1.1, 2.0, 3.0, 3.1, it's pretty
Oh,
in-depth.
John, don't say that. The DOCSIS manual does not put Brady to sleep.
So I mean, I did struggle with this because I think, you know, to your point, I think our industry is really unique, that there's even having a BS degree, that doesn't necessarily mean you're qualified to work in the industry, because there's so much you have to learn. But at the same time, if you get a BS degree, I would probably go, I'm torn as to whether or not, you know, if you want to get a degree, I think that's great. I'm torn as to whether or not you'd go the electrical engineering route, which I think gives you a lot of good things on a theory side of how RF works in sort of the field of, it gives you sort of the basics, a nice fundamental, which is very helpful. At the same time, computer science might be very helpful, because that's going to tell you a lot about routing and how the programming of things works if you're working on CMTSs, if you're working on routers and all that side. So those are kind of two different ways, maybe two different programs.
Maybe it depends more about the university, because we don't really know where this person's close to. So I would probably look into the university close to you. Of course, since all of us went to Penn State.
All of us.
Yeah, but also, I mean, Georgia Tech has, of all the schools I'm aware of, I think Georgia Tech has worked most closely with the SCTE for developing content relevant to the cable industry.
That's true.
So that might be a great school to look at if you're.
But I would recommend wherever you are, because depending on where you live, because I'm sure he doesn't want to give up his job to move to Georgia or Penn State. And
to your point about, you know, to your point about the basic stuff, you could get that in the first 2 years. So the question would be, do you really need a BS or just a 2-year associate degree to get the basics? And then the other side of it is RF dying?
We've had that conversation recently.
Too,
I think RF has a very finite. There's going to be a very finite number of jobs in the.
It's definitely going to be a niche field.
So
because we're going remote PHY, we're going more digital, so everything's IP.
But that's just in broadband. I mean, maybe there's other industries that still use a lot of RF. So,
but I think starting off with if you're not looking at the BS, starting off with a lot of like the CCNA courses, the Cisco certified courses, that gives you so much knowledge about routing and configuration and stuff like that. The SCTE courses, there's a lot of good training there. So that's a good way to start as well.
There's a lot of stuff online too, so I guess it really depends on where you want to go.
Yeah. So I think we've covered that question. Yep.
I think we tiptoed around it very well. It's like if it was my son, like my son says, what should I get into? I'm like, should I say this on a live thing?
You probably will anyhow.
Return on investment for a 4-year degree is tough.
Yeah.
For kids today coming out with $100,000 loans, it's like, for what? You know, a 2-year degree in a trade has a better return on investment than a 4-year degree in an engineering degree. It becomes difficult unless you keep up with technology, you keep up with networking with actual people, not just socially on social online.
Yeah.
You know, networking, that's why we go to these events too, right? It's part of networking. Press the flesh. People get to know you, and you learn more information. And the more you learn, the more you realize you don't know. Ignorance sort of is bliss, isn't it?
It is indeed.
But it's tough. But knowledge is power. So the more you learn, the more you're gonna have the opportunity to network and promote yourself and market yourself.
Yep. I will say, like, Stanford University has amazing online courses. There's like Coursera online. There's what are some of the other ones you've looked at, Mia?
I don't remember right now.
Yeah, but there's tons of stuff online, absolutely free. and you can increase your knowledge in so many areas.
But I think that's to John's point. I mean, there's a lot you can do now online and not necessarily go to school, to a formal education. And to your point too, you can actually have a better return on investment on learning a trade than maybe getting a degree. I think if you go to school, you should really have a focused view of what you want to, you know, where you're going to go. So
Agreed.
if you don't know where you're going to go, you're wasting your money.
Yeah,
So,
or your parents' money.
yeah.
That sounds a little selfish there, John.
What do you say? Well, I think everybody paid for. I paid for school myself. So.
Yep. Same here.
But we're open for adoption, John.
If you want to put me back to school, John.
Pay for me to go back to school, it'd be great.
I have a boat, and it says College 529 on it. Basically, use my son's money for my boat. No, just kidding.
Beautiful. All right. So, closing comments. It was a good show. I had a good time.
It was good. I think SCTE was good. Looking forward to having it in Atlanta next year, and it'll be interesting. I think last year's SCTE had a lot of like new and exciting things come up. This year, I think it was more of an evolution of where these things have gone.
They've matured.
Yeah, they've matured. So, yeah, I think it was good.
What's your prognostication?
The prognostication
For next year or for ANGA?
Next year for SCT and Expo.
in Atlanta next year?
I think we're going to have deployed.
Like you look in your crystal ball and you look at all the shows and how people can get information so quickly on webinars and these Google Hangouts and stuff, instead of having to wait every year to go to an expo. How do we draw more people to the expo? Or do you foresee maybe the expo combining with NAB, or the expo combining with, well, it would never combine with CES, but is there another industry show that would make sense to combine with? And that's what I wonder.
Yeah, I mean, I think it, like you said earlier, it's already started happening because we used to have the Western show that disappeared. Then we had NCTA. That's no longer around. There's that other one. I can't remember.
Emerging Technologies would be a good one.
Yeah. So, I mean, it probably would be good. I think the industry has been consolidating, and SCTE is still a decent show to go to, but
I think it's one of the last big technical shows in the U.S., right? So I think it'll have legs.
Broadband, yeah.
But it'll be interesting to see in the next 4 or 5 years how we keep everyone invested in going to this and drawing more people.
I think it goes back to the old saying, evolve or die. So,
yeah, evolve or die. Yep.
Evolve or die. So unless, I think the SCT has to continuously evolve. I think it also has to remain technically strong and not let itself backslide into more of a marketing thing, kind of like what you were talking about earlier. You know what I mean? Where I think the worst thing is if you paid for a session, you go in and you feel like you've just listened to 30 minutes of a marketing pitch. So I think remaining technically relevant is really important for the SCT.
Yep. Yeah, the other good thing is, at the workshop, I did a presentation, but I used to hate it, but I look back and I'm like, it's a good thing. We have to write a technical paper to go with the slides. Yeah. So when someone goes to my session, they can download the paper and get exact details. I mean, I can go into CISCO details because I'm not presenting it, but it's in the paper.
Right.
So they can look at my paper and almost like a cookie cutter and say, all right, I'm going to do the exact configs to get the speeds that John said I should be able to get.
Right.
Yeah.
Well, that's what that cable operator was talking to me about from Switzerland, where he's like, yeah, this is great because you get this big technical paper to go along with it. So, yeah.
The technical papers are very valuable. Even though I think a lot of people don't download them and read them, the people who do download and read them find them incredibly valuable.
Yeah. Well, I think the point is that some people do download and read them.
So. All right. John, well, thank you again for joining us. Mia, thank you for coming online and joining us.
another 15-minute Google Hangout.
Yeah. The shortest
Whatever.
hangout ever. Like just when we started talking about it a couple years ago with John. Yeah, it'll just be 15 minutes.
Yeah.
It won't be very long.
Yep.
Mm.
And
There
for
we
all of our audience, please, if you liked it, click subscribe or add us to our podcast and click subscribe and give us a thumbs up.
Yeah,
Thank
you
you
can.
for joining.
Yeah, you can get us on iTunes and Google Play too. So.
Yep. So, all right, everyone. Thanks and so long.
Bye.
Thanks. Bye.